Hello, in this video I'm going to cover the ELB blueprint. The ELB blueprint can be used to both create both an application as well as a network load balancer. But in this video I'm going to specifically create a network load balancer and show you how that's done. Several properties of the load balancer are configurable via parameters. Additionally, if parameters don't do the job, then we can use variables to configure additional properties. By default, an application load balancer is created, so we're going to actually override that in this demo video. You can assign existing security groups to the ELB if you have them, or you can have the blueprint create and manage a security group for you. So there are pros and cons with each approach, but it's flexible, so you can do either. A listener and target group is also created and automatically set up. You can create an optional managed Route 53 record that points to ELB. And generally, I don't create the ELBs by themselves like this unless I'm doing kind of just learning and experimenting. Sometimes I have, but usually I create a ELB with the auto-scaling group and they're just all connect together. There's another blueprint for that, and I'll cover that in another video. I just want to briefly mention that. For this blueprint, though, the usage here is just to add the blueprint to the gem file. You configure some values, and then you deploy. Here's the add command. Not the add command, but the line that you add to your gem file. Then to configure, you run the lono-c command, which generates essentially a bunch of starter configs. And then from there, you can just tailor them to your needs. Then you just run the lono-c and deploy, and that's it. There's some more details on configurations down here that's worth covering. So security groups, you can use existing security groups by basically assigning a value to security groups parameter right here, and it's a comma separate list of existing security group IDs. Now, if this is not assigned, then managed security group is created for you. If managed security group gets created for you, you can actually specify the ingress rules here with a variable. So these variables will be used if a managed security group is being created, and then basically you can whitelist what you want to do here. For example, these ingress rules are whitelisting port 80 and port 443 to the world. Pretty much any load balancer attribute is configurable via this variable here. So you just basically just set it here, and it could be all codified, so it can be consistently deployed across environments and everything. Pretty Route 53 records are supported too. You automatically have a Route 53 record, and that's going to be associated with the load balancer's DNS name. SSL termination is supported. You just provide the certification, the certificate ARN here via certification manager, and then you set the port and protocol. Registration targets actually via code is supported also here. Again, this is a standalone load balancer, so by default there's no targets associated with it. But you can actually, if you wanted to, associate some targets with it, and I actually have done this before. Okay, network load balancers. That's actually what we're covering. So this is important to go through. So if we want to use network load balancer, then you have to configure these properties, these parameters at a minimum. You have to change the type to network, you have to change the protocol to TCP or one of these other supported protocols for network load balancers. Otherwise, the stacks can grow back. So this is actually very important for this demonstration here. Target group protocol also needs to be one of these supported protocols. It can't be HTTPS because network load balancers, I believe they're level 3, layer 3 load balancers, so they're lower on the network stack, and application load balancers, I believe, are layer 7. So because this is a layer 3 load balancer, it doesn't support those protocols. Those protocols like HTTPS and HTTPSS, those are layer 7 protocols. So it's not going to work. So we have to use protocols that are only supported by network load balancers. So here are the examples of the supported ones, at least right now. And this is kind of an important point. So one of the reasons why people might want to consider using network load balancers is because it provides one specific feature that's quite handy if you have this requirement. It provides static IP addresses. So application load balancers, the IP addresses are going to not be static. They're going to just be completely dynamic. Application load balancers, they just add virtual nodes automatically as there's more traffic that comes in. Static load balancers, you actually, since they operate at layer 3, they're more performant, and because of that, AWS allows you to allocate static IP addresses on a per subnet basis to each of your static load balancer nodes. So in order to use static IP addresses, you can actually just have CloudFormation created. But the whole point of static IP addresses is to maintain the same IP address. So the way you would do that is you actually pre-create EIPs, and then you would take those EIPs and then those allocation IDs here, and then you assign it here in these variables. So that way, when you spin up your load balancer, it always uses the same IP addresses, and that's what basically clients will see. So if you do need to then create a new load balancer, you have to actually destroy this one and release it. So it's probably always a good idea to create a couple extra IP addresses, so you have some IP addresses for maintenance windows and kind of to blue-green it out. Okay, but this is kind of important here for load balancers, because that's one of the reasons why I actually use network load balancers. But these two sections are pretty crucial, so we're going to go through them again as we launch this network load balancer. But that covers pretty much everything. The advanced properties here is just saying you could override any property you want to. So that covers pretty much everything. So I think we're ready to go ahead and jump to the demo now. So I'm going to go ahead and do that. I'm going to grab this line of code, go to the gem file of the project, and paste it in. But of course, I'm not going to use that because I've been using this handy kind of wrapper method that makes it a little more concise. See, same thing because the method's right there. So once that's done, you could bundle, and then you could run lono seed ELB. That's going to generate these configuration files right here on the left-hand side. So here are the parameters and variables. Like I said, variables, we can configure different things, but I'm going to focus on parameters here. Okay. So parameters. So let's look at all the required parameters first. Subnets. So this is required. You need at least 2 for. I'm going to use a handy method that's built into Lono, a helper method called default subnets that returns a list of default subnets. For the sake of simplicity, I'm just going to launch this in the default subnet. You can launch this to any subnet, obviously, by basically configuring this parameter. But I'm going to use this helper method called default subnets and just join it because it returns an array. So I got to join this with a comma because this actually specs a list of comma separated values. Okay, so and you need at least 2 for network load balancers or application load balancers. You need at least 2 for high availability. It's actually a requirement. Okay. For VPC, I'm going to also use default VPC. That's another helper method for Lono, and it's all documented on Lono documentation page. So that's all you kind of need. But right now we're going to have an application load balancer. So we want to change this type right here to network. So that's kind of it. You kind of now we have a network load balancer. However, like I said, the README cover a couple other things that we need to adjust to. So this type network, but we also need protocol, TCP, and target group protocol. Because a network load balancers work at layer 3, so they don't have HTTPS, which is the default, so we're going to have to actually override those. So we were looking for what? Protocol and target group protocol. You just search for it. There we go, protocol. So this needs to be TCP for network load balancers. I like to put these all on top after I kind of move them. And then let's grab the last one, target group protocol. Right here is down here. It's the target group. So one's associated with target group, one's associated with the listener. So this one needs to be TCP also, or else it won't work. Right? And then down here, we're talking about subnet IDs. So like I said, in practice, I would probably pre-allocate the EIPs and then use those. So then you can maintain the static IP addresses if that's what you need, and that's why you're using network load balancers. Okay, so I'm just reviewing everything. I think everything looks pretty good, so I'm going to go ahead and launch it. Oops, let's go down here. Okay, Lono CFN, deploy ELB, sure. So that should go ahead and launch the network load balancer. Okay, so there we go. The parameters you can see were passed differently here. And the create in progress has started. So let's go ahead and verify this on the CloudFormation console also by refreshing. There it goes. Create in progress. We can see the events here. Okay, and it's going to take a couple minutes to create the load balancers. I noticed network load balancers actually take a little longer to create than application load balancers. Not that much longer, but it seem to be, it takes the provision process seems to be a little slower. Okay, so I'm going to go ahead and pause because it takes a couple of minutes and y'all don't have to wait. Okay, it's finished, and that didn't actually take that long at all. It's about the same amount of speed. So it took about 2 minutes. If you see right here, you see 2 minutes and 43 seconds. Well, let's check out the resources that were provisioned. Right here, there's ELB, a listener, and target group. And to verify for completeness here, let's go to the EC2 console. On the EC2 console, we're going to click on load balancer. You can see the load balancer, and you can see type network. There you go. With all the subnets here and the VPC. When we click on listener, you can see the listener right here, and you can see forward to target group right here. So let's look at the target group. So there's the target group. And pretty much all these properties and everything is configurable via parameters, configs, and variables, okay? That pretty much covers it, and that shows you how to use this BoltOps Pro blueprint to launch a network load balancer. Okay, hopefully that video was helpful. Cheers.